to that at this point. Okay, so let's look at the reciprocal identities. The reciprocal identities are going to be identities that are fractions. Okay, so 1 over sine theta. Secant is 1 over cosine theta, and cotangent is 1 over tangent theta. Sine is going to be 1 over cosecant theta. Cosine is going to be 1 over secant theta. And tangent is going to be 1 over cotangent of theta. Okay, pretty straightforward there. Moving on to this next piece. Tangent and cotangent. These are ratios here. So tangent is going to be sine theta over cosine theta, and cotangent is going to be cosine theta over sine theta. Okay? Down in this Pythagorean theorem, Pythagorean identities box. Remember, these are going to be extremely useful for us. The first one is going to be something that looks a lot like the Pythagorean theorem. Sine squared plus cosine squared, or cosine squared plus sine squared, is equal to 1. And derivatives of this, or things that come from this, sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta. Okay? And what we've got is, if we're going to pick one of these, I'm going to put a little arrow here. So if we have sine theta, we've taken the square root of both sides, so it's going to be equal to plus or minus the square root of 1 minus cosine squared theta. And our cosine here is going to be, for simply finding cosine theta, it's going to be plus or minus square root of 1 minus sine squared theta. We've used these before. These are pretty familiar to us. The other two identities that are going to come out of this are going to be 1 plus tangent squared theta is equal to secant squared theta, and 1 plus cotangent squared theta, should have a theta in here, is going to be equal to cosecant squared theta. Okay? General guidelines for doing these trig proofs. Well, number one, we are going to pick the ugliest side. And what that is going to generally mean is the one that looks hardest. Or most difficult. Okay? The second general guideline is going to be to try to change all trig functions to sine theta or cosine theta. Okay? And general guideline number 3. Is only work with one side. Okay? So 3 basic principles. We've used them before, so we are going to make sure that we do these things once again. Okay, so those are our general guidelines. Let's look at a couple of examples. I have 2 here, and that'll be the first part of this. So when I'm looking at this, and I'm exploring my general guidelines, maybe I'll leave those up at the top here. For example 1. I want to pick the ugliest side. This is a cosine. It's pretty simple, so this is going to be the side that I'm going to go with. Okay? So I know I'm going to be working with just this side, so I can bring the cosine theta down. And my goal is to try to make it look like cosine theta on this other side. And so my second one is to try to change all trig functions to sine or cosine. Well, this is already sine theta, so I'm going to have sine theta. And I'm going to change this cotangent into, like I said up here, sine or cosine. So if I flip up to the top, you should have this written in your notes. Cotangent is cosine theta over sine theta. And so I'm just going to put that in here. Sorry for the scrolling around. This is going to be cosine theta over sine theta. And I'm going to remember here that this is going to be sine theta over 1, and I'm multiplying. So this sine theta is going to cancel with this one. So what I'm left with is cosine theta on this side and cosine theta on this side. So I'm going to put a check mark by there because I've shown that when I reduce things and when I make them look different, this side actually is equal to cosine theta. Okay? So we're going to apply the same principles. I'll leave up example 1 and we'll do example 2. This one is one of those ones where it's like, well, we just did an easy example. Why are we doing this one? So here's another more difficult example. I'm going to pick the most difficult side. While this one has an addition sign, this one has addition and multiplication. So let's pick this side. So I'm going to leave this one as tangent of x plus cosine of x. Now, what I'm going to do first, I am going to try to convert everything over here to sines and cosines. So let's see how I do this. Leave this as sine x. Secant x is 1 over cosine of x. And cotangent, we remember from up here, was cosine theta, or cosine of x, over sine of x. And what I'm going to do next is I'm just going to distribute. Okay, so I'll use a different color here to denote this. I'm going to distribute. And what I end up with is sine x times 1 over cosine of x plus sine x times cosine x over sine x. I still have tangent x plus cosine x over here. Okay. Now, is there anything I can cancel? Because remember, up here, I am only working with one side, so I'm only working with this other side, so I'm going to simplify. Well, I know that this is going to be sine x over cosine x plus, now these are going to cancel out. So this is going to be cosine x. And if I look back up at my trig ratio, sine x over cosine x is the same as saying tangent. So I'm going to reduce this to saying that this is equal to tangent x plus cosine x. Well, looky here. Tangent x plus cosine x. Left side equals the right side. Check mark. We are done. That's another basic intro to trig identities, to proving those. Thanks for watching, guys. Stay tuned for part 2.